This is actually in text coordinate. And in out whatever same stuff. Alright, you have the shaders, and we also have to create the shaders somewhere. Where is the shader? Initialize, create program, we create the shaders here. We compile the shaders and validate them. It's quite lengthy. And we print the. So we can do this in another function. Void graphics. Create programs. Program. Shader program. Alrighty. So we have a program which is, I think, integer. Right. Let's get them. Program pixel shader, vertex shader. We just have one. Simple like that. So basically we are not going to do any DirectX, any Vulkan, any metal. We are just going OpenGL and SDL. This is a simple game in terms of rendering, so OpenGL should be supported if we really want to run it on mobile or whatever, no problem. Otherwise we would like abstract interfaces for the, or some inheritance for the graphics and so on. But we don't need that here. Okay, so we create the pixel shader from the source code. We check the errors, we compile, attach the shaders, the usual OpenGL stuff, linking the programs, all the pixel shader stuff. Okay, get boolean and boolean. And it should be just fine. Here we are printing the attributes. Okay. Okay, so create shader program. All right. Okay. We also need a buffer or vertex buffer to draw quads. I have something here already made, and maybe I should use it. So we'll just copy and I will explain it. OpenGL vertex buffer and probably texture array. Two simple classes. Let's just call it simple because we only have OpenGL anyway. Okay, let's update our solution. Reload it. Let's see what we have. Okay. First, the vertex buffer. We don't have these. We include the types. Alright. It's just a simple vertex buffer. Okay. Vertex. We don't have vertex. Where is the vertex? Somewhere in include, I think. Oh, it's still case sensitive. What is vertex? Ah, sorry. Vertex is here. This is the vertex. Point, we don't have point, we have vec2, vec2, uv, we call it text coordinate, but it's okay, uv. Yes, this is the texture index. Also include vec2. Alrighty. So we create a vertex with the vertices, or simple. We can resize, you can upload the data, update the data, we can destroy it. We don't need this. Perfect. Then we get to the vertex buffer, graphics, if it's needed, but I don't know if it's needed. Not needed. We already have glue, so not needed. Probably this needed, but I don't know. This is to copy stuff. Engine. Okay. Let's replace this with a vertex buffer. So this is one lesson to be learned when you create software. You can reuse parts of your code. This tutorial is not really the perfect tutorial where you start from scratch. You do not look on Google, you do not copy code. This you will do it naturally and just help yourself. There is no shame on that, at least for me. Okay, vertex buffer, create one what? Number of vertices. Okay, create, check error, we can use it then. Graphics, check errors, update, blah blah blah. Okay, we don't need this one, and that's pretty much it, the vertex buffer. Perfect. Let's compile. Okay, we have a problem. We don't need to override. We know what API we have. Perfect. Now let's get to the texture. Alright. Clean this up. Include the types. Include probably the graphics. Or not. Let's not include it. engine. We can rename it to just texture array. There you go. We don't need this. RGBA, it's actually very simple. Type def U32, U32, just RGBA, 8-bit. We'll use PNGs with 32-bit colors. We'll not use indexed colors, indexed palette. We can fake it somehow. We'll see later if we really need the palette animation. Alright, we don't need to override anything. We don't need this. There you go. No virtual. I don't even need. Can just take it from there. This is a rectangle. I don't know if we need rectangles. We might need it for the sprites. Should we? I have the class, so it's okay. Okay, let's take the rectangle also. Maybe we'll need it. So rectangle, it's just a simple rectangle class. No, I just want to see it. Rect class. Where are you? Okay, you are here. With a lot of operators, you know, all the good stuff. So let's create a class for the rectangle. I think everything is all in line, so it's okay. Just add it, generate. Alright, yes, save them. And we should have a rectangle. Okay. Add now once. Actually, let me check something. Have I added? Okay, it's added. Okay, include types as usual. What else? Nothing else. Namespace engine. Okay, so this is a simple rectangle in 2D space, and we have a lot of. Yeah, we don't have point. We have vector. And we have to include it. Vec2 is more, 2D. I used point for the GUI library I wrote. So basically all these functions are and classes are taken from my Horse GUI library, which you can find, let me check, Horse UI. Okay, in GitHub. There you go. So this is a library like the dear EMGUI, which you can use to make cool custom, not custom, but immediate mode GUIs for your applications. It has full scaling support. It's pretty nice. So that's why I'm taking code from there, because it has a lot of classes and systems that I will use in the sprite rendering. I probably will take the atlas and so on. So go ahead and download it and try to use it if you want. This is the address. Okay, let's continue with our rectangle. I think everything is okay. So we were on the texture, right? And we have to include the rectangle. Alright, perfect. Now let's get back to the CTP file. Texture array, maybe graphics, but I don't know if we need it. I'm using namespace engine and not just leaving like this. Usually I leave it like this, but I think it's okay to just using it. We'll see if we will have clashes, but I don't think so. And this is a bit lengthy file, but not that much. Just text creation in OpenGL. Yes, you need the graphics also. Alright. So just creating textures, texture arrays. You can update the data with all the slices in the pixels. Update a specific layer, the texture index. We don't use MIPS. If you want to update a specific rectangle data of texture index, destruction, and that's pretty much it. Let's see if it compiles. Compiles perfectly. Alright, so we have textures, we have vertex buffer. What can we do? What can we do? Yes. Okay, we also need in graphics to set up the camera, which is basically I could set it like a very normalized space, but yeah, let's just do it. Set up camera or projection or something, because we don't really have a camera, we have a projection mostly. Okay, camera, set up camera or projection, limit. Void graphics setup projection, and let me check the projection. Of course, we get back to our code and I will explain it. Where is it? Should be around here or in the vertex buffer. No. Yeah, this is the where is it rendering it. So this is like some other stuff. Okay, we can use the program because we want to render with the program. Okay, these are batches basically, like the vertex batches. Maybe we should use it, maybe not, I don't know. Actually, I could even copy everything. So our texture, yeah, this is setup frame, maybe, I don't know. We will have only a single batch. We do not change the textures, so we don't need the texture. We will have the commit render state, we will do it later. Okay. We will have a single texture array, so we can even create it, which will hold basically the entire, all the textures. We have like structure, texture, array, texture array. Okay, let's create this. Texture array equals new texture array. Width and height, we'll see. I actually, so we have many texture of, I don't know, 2048, right? 2048. And how many? One for now. One, that's it, right? Okay, RGB pixels. That's okay. And we have to include it. We also have to include the vertex buffers. Where is it? Okay, let's also make a vertex buffer. Vertex buffer. This is the main vertex buffer basically, where all the game elements will be rendered, from scoring to enemy ships to player ship to backgrounds to whatnot, everything in one single call. We want one single call. Okay, so let me check. We can create the vertices. If we create update vertices count, we can just create it and then just resize it like this, and vertex buffer resize. How many vertices do you want? We'll want a constant somewhere here. Static const 34 max vertex count would be, so if we have a quad which has 6 vertices, so 6 vertices multiplied by how many quads can we afford? Okay, 1000 quads, or even more. 3000 vertices basically. Max vertex count. should be enough for now at least. Alright, resize. We could also push the render target to bleed it. But we'll see. Okay. And I have to set up the frame. Well, also let's take the commit render state. So this is basically for render state setup. Okay. Can be done once probably. Yeah, this is like blending stuff. Disable the cooling of faces. The polygon mode is filled. We disable the depth testing. We just draw one over the other. Alright. Where are you? Okay, here. Setup frame. Let's also add it. It's here actually. Setup frame. Okay, we don't have a badge, so our texture is handle. Okay. Why am I doing that? I shouldn't do it. It should be simple like this. Okay. Just a second. Okay, so we set up the program. We set up the texture parameters. Clamping, and this should be nearest or what was the other? I don't remember. Point or what? Shouldn't be nearest. Yes. The heck. I forgot. And this is the matrix view projection, which is basically pixel. It's pixels, but I don't think we need pixels. I think it should be just identity, right? Why am I doing it that? Let's at least do it like this, and then we'll probably do it better. And let's see. just to have something on screen. We upload the matrix, we don't use the program, and then we bin buffer and we render the vertex buffer handle. Okay, we render it here. Now we basically define the attributes. So we have the position, vertex offset. I think I have it somewhere. Where is this? Maybe somewhere around here. Oh, okay. Actually, I have it right or not. Alright. Then we have the in texture coordinate, color, texture index, and now yeah, we only have triangles. We can do like a fan, but yeah, I don't want to complicate things. Okay, the vertex index is 0 and the vertex count is vertex buffer vertex count. Yeah, we need it. Vertex count. We need to add it to the vertex buffer here. Equals count. Alright. Maybe we shouldn't do this like GL use program because we have only one program, but I'll just leave it like this for now. So this is basically at the beginning of the frame. Setup frame. Actually, no, at the beginning. It actually renders the frame, but it doesn't render the frame. Is presenting, I don't know, draw frame, I don't know, draw. Alright, so we have, let's draw a quad even without any texture to actually check it if it works, right? So how do we do that? The thing is that we have the render target bound, so it will not render into this one. Maybe we should skip it for now. Let's skip it for now. So we just render in in our buffer, and in the game, in the main loop, while not exiting, this is the input basically, doing input stuff, and let's try to do it here. The game has a graphics, right? Has. So it's draw frame, but before drawing frame, let's draw something in the vertex buffer. So we have we need something in the graphics. In the graphics itself, we need to draw quads. Actually, this is better as present frame, maybe. Yeah. And we can also do the GL swap with swap this. And the clear will do it in a special function, clear frame. Actually, it's even better. Begin frame and end frame. Way better. Okay. And it's called end frame. Void graphics begin frame. And in the begin frame we have the clear. And we also have some other things for the vertex buffer, which we will fill with quads basically. Vertex buffer. I think I have something in the renderer here. Yes. Let me see what I can grab from here. Since we'll have a single buffer, so we'll have the vertices. Actually, I can resize it. Yes, that's okay. Okay. Vector. So here we'll have all our vertices, the whole scene basically. This is the draw vertex count, how many vertices to be drawn, but this will hold the maximum number of vertices, and we'll only draw the draw vertex count, how many we use. If we'll need more vertices, this will be the grow factor. How we will multiply the vertices size with this one, and we'll resize the vector. All right. What else can I get from here? Okay, we don't need clipping. We don't need that order. Okay. So we could have a current color, but we can just use I just draw the quad, draw some solid quad. Okay. I know now. Yeah. Okay. So what we'll have? We'll have one buffer. No. Okay. No. We have current color of the current quad, the atlas texture index, and that's pretty much it. Current color is 0 or even white. I don't know. Basically, this is RGBA color. We can even use the RGBA 32 if we really want. Okay, it's packed. And now we want to basically add some quad. Draw a quad. So it's a rectangle, and we need the UV coordinates of the quad. Let's check it out in the renderer. Draw quad. No. And okay. Basically, we draw two triangles. Okay. No, wait. This is another function. I think this is the one we want. Okay, let's see what we have here. Graphics. Draw the quad. We need this function, which will do the resizing. So this will resize our vertex buffer if it's too small. Okay, this is draw vertex count, vertex buffer, vertices. Alright, we already have space. Okay. So making an arcade game from scratch, it's not even from scratch. We are using some code, we are using libraries. Just imagine how much time it would take basically to do it. It's a lot of work. So I really, if you are not doing it, if you are doing it for money, probably it's better to just use Unity or Unreal Engine to have already like sprite engines and whatnot. We are doing this just for fun here, so, and for learning. I'm even myself, I'm learning new stuff as I go. Okay, so we are resizing the vertices by the grow factor. I think it's okay. Is it red? Okay, we'll see later. Insert Okay, begin end. Vertex buffer is size with the current vertices. Alright. So what's the problem here? Vector vertex. Vertices and vertex. So what's the problem? Something is wrong. So we don't need the vertex buffer data. Let's check this out because what the heck? Why is not working? Because I want to just copy conversion from std vector error type. But I should have vertex or not. Vertex. Include maybe like this. But the problem is that I also include graphics or not. I don't include it, I think. So it should be fine. Okay. Yeah, so basically we are drawing the quad. We are putting it, I should stop it basically. We are copying the quad positions into the vertices I for all the 6. Okay, we don't need this function here. It's just a rotated quad used for text. Okay, vertex count equals 6. But I don't think we actually need it. Yes, we don't need it. Okay, so we draw the quad. I think that's pretty much it. I draw vertex count. We should reset this when we begin the frame. We should reset the raw vertex count to 0. Alright. These are 0. Okay. Vertices, it should automatically resize. Where is it? Vertex buffer, we can resize it, but it's okay, we can resize it. Yeah, why not? Vertex, vertices, resize, max vertex count. That should do it. Let's compile. We have errors, of course. Let's see. Current color. Yeah, let's just leave it like this for now. What? Rectangle, I think. Include rect. present frame. Yes, it's not. It's begin frame, and then graphics. Yeah, and frame. And let's try to draw something. Graphics. It probably not to work, but we'll try. Draw quad. The rectangle will be from 50, 50, 100, 300, 200, and the UV rectangle will be 0, 0, 1, 1, the entire texture. Let's run it. Okay, nothing. We can actually disable blend for the moment. Okay, create a program. Everything is okay. Let's disable for now. Still nothing. End frame. Let's see if we actually get something. Okay, program with sampler. Okay, the view. Viewport. We haven't set any viewport. Yeah, let's set the viewport. Here viewport, which is 0, 0, game window width. Probably it's not like this, but we'll see. Something like this maybe. Okay, still nothing. Yeah, it's until you get the first triangle on screen. Let's see. Let's see if actually we get here or here. Okay, we have something. Let's see how many vertices we have. Actually, we shouldn't draw the whole thing. Yeah, too many. We should draw only. Wait. We should draw vertex count. Triangles. Okay. 6 triangles. Good. So where is it? Where is it? Okay, let's change the color. Draw vertex count. Maybe we should change the color. Graphics current color equals color blue. To RGB, get RGB or not. Come on. Include color. Alright. Current color. Let's do this. Probably not. Nope. Let's put a gray here. Okay. So what else did we forget? Okay, so the viewport. Yeah, this is just other stuff. What did we forget? Width, height. This should be okay. GL viewport. Draw view count. Maybe there is something there of the texture. But wait. There might be something here. Yeah. Maybe something here right now. But it shouldn't really. Why, oh why? Something wrong? No. Ah, wait. In position it should show all the... Wait a minute. It should show all the parameters. So why isn't it showing everything? Why? We have a problem. There is something wrong. Don't ask me why. I'm just putting them back. Yeah, it's weird. Anyway, let's continue. Just let's put a final color. Um, out color, out color. Okay, out color is yeah. There you go. Hmm. Am I bending the? Yes, I'm bending it. Wait, I think I updated. I don't think I updated. I should. Wait a minute. I do not update the vertex buffer. Hmm. Yes, I do not update it. I do not update the vertex buffer, which I should. And you update it like this. Let's go back and put back the color. And let's update the vertex buffer. We don't. It was something like batch. Where is it? There was something batching, and there was update. Yes. So we do fill the vertices, but we do not update the vertex buffer, which should be done somewhere. Vertices, draw vertex count. Yep, they should do it. Or not. Um, or not. We can actually even visualize with debugging update data. Come on, why don't you update it? So if we forget there, then it's okay. Okay, 6 vertices, nice. Color is weird, because it's blue. UV, I guess it looks good. But where is our quad? Why? What's happening? The render state, no depth testing, no nothing. What's happening here? Where should we look? Okay, time for render doc. Render doc will help us let's actually run it and check with render doc. Where is it? What the hell is it? Oh. Attached to running instance. Okay, never mind. Capture executable. Alright, you have to kill it. Launch. Allow. Okay. Trigger capture. And stop. Alright, let's see. Texture viewer. We have the back buffer. What? Okay, the back buffer. Okay. What else? Um, Mesh. Do we have any vertex? Vertex input. Why? Okay. Frame start. Okay, vertex. Vertex looks okay. Gear position. Out color 001, which is blue, which is okay. Texture coordinates look okay. Text index is 0. GL position. I don't know about that. Why is it 1 1? Ah, okay. 50, yes. Probably. Yeah. Okay. But why is this one? This is not okay. What's happening in the vertex shader? Mr. Vertex Shader, what are you doing? Is it the vertex shader or is it me? GL position. Because the input looks okay. 50-50, 350 and 50. Actually, should that be? So this is the first vertex, this is the second vertex on the Y. Let's see our game sample. So 50-50. Let's just put 51, 121, but it's the same anyway. Yeah, it's okay. Okay, inputting 50-50. Yes, 150. Wait, 250. What? Ah, wait. Yes, 350 is the okay. 250, yes. Yeah. But my problem is that only the X position is okay. Position. Why is it 1? 1, 1, 1? Something is wrong here. Why? It's in the shader. I don't know why do we have that. Test coordinates. The out GL position V matrix V position. What's going on here? Something is fishy. But it should work. Ah, wait a second. Don't tell me. I hope. Yeah. Well. Keep everything in float. Shall we? Wait, I cannot. Because it's still running. No. But now it should work. Where do you still use this? Okay. It should be okay. like this actually, I think. But I have this hunch, I don't know, probably. Come on. Okay, let's make them float. Yay! Great. Freaking floats. Yeah, so you have to keep the floats properly. Actually, if we only do this, let me check. I mean, it should work, right? Okay. But if we do actually, forget this. Okay. Yeah. Dividing a float by an integer will result in an integer. The usual lesson. Okay, so let's see in game here. No, not game. Actually in game, right? Yeah. So let's put it a little bit down. Yay, so we have our first rectangle. Isn't that magical? Is this actually running? Let's move it a bit. Let's put some rect2. Pos should be static. This is just for testing. Pos dot y plus 1. I don't know. Pos. Let's see. I think it's okay. That was funny joke. Okay, we have something running. So this is our first rectangle thingy, which it seems to work. Let's fix the graphics, the shader. Okay, actually it's fixed, it's okay. This is also okay. Alright, I think it's okay. So that's pretty much for now. On the next episode we'll do texturing to actually see some texture on the screen, and we'll probably reactivate the render target and bleed it to the window, but actually the render targets. So we'll render the render target with a code, setting the render target as a texture. Alright.